This is Tom. Today we're going to be using Photoshop and the Geographic Imager plugin from Avenza to process satellite data and create a beautiful natural color image. It's going to be a fun project. I'm going to pick a pretty difficult image to process, and I think we'll learn a lot. What we'll be doing is using Sentinel satellite image data. Sentinel is a product of the European Space Agency. The first of two satellites was launched in 2015. They take images of the same place on Earth every 10 days. And because the orbits are staggered, they will image every place on Earth every 5 days. So there's a good library of images available worldwide. Or I should say not worldwide, but for land areas on Earth, excluding Antarctica and some smaller oceanic islands. So the coverage is pretty good. What's more, the native resolution of Sentinel images is 10 meters on the grounds, so it's pretty high res, and they cover a pretty wide area. The image swath is 290 kilometers wide, about 180 miles. So when you download an image, you see quite a big area. So the first thing you need to do is actually get the image data. And to do that, we're going to go to our web browser. I'm on the USGS's Earth Explorer data portal. You can see the URL up here at the top. It's earthexplorer.usgs.gov. The catch here is you have to create an account with them to download data. There's no cost at all. The data is free for the taking, fortunately. I've already logged in. You can see that it says Mountain Maps. There's my username, but I won't tell you my password. And now what we have to do is, once we're logged in, is just find an area of interest to create a satellite image of. So let's zoom out, and we're going to go northwest to the Alaska, British Columbia border area to the Stikine ice field, which is a really kind of beautiful high mountain area, and I like high mountains. So let's zoom in on an area there. And to select your area, just go over to the left, and you'll see this little button says Use Map. It'll select that area in your map window as your study area. You can see the coordinates here on the left as well. Then you have to select the type of data that you want to use. So we'll go up to the top to the Datasets tab, click there, go all the way down toward the bottom. There's the Sentinel choice. Hit the little checkbox, and some text dialog comes up. We'll read it very carefully, click OK, and now we're ready to get our Sentinel data. But we want to probably refine the search criteria a little bit. Presently, we're searching for all months of the year, and we don't want to do that because in the wintertime at this northerly latitude, it's pretty dark and there's long cast shadows, and we won't really see much of anything. So let's deselect all months, and if we were to be mapping, say, glacier extents in this area, we'd probably want to get an image from late September when the end of the summer melt season comes about. And but we're not going to be mapping glacier extents. We're going to be using this image for a drape on a 3D scene, and 3D scenes generate their own shadows. So if we pick something that's taken near summer solstice in June or July, the shadows embedded in the satellite image are going to be pretty small, and that would be more ideal for our purposes. Also, there's going to be a fair amount of snow still up in the mountains, which is very pretty on in a 3D scene. Plus, the lowlands will have vigorous vegetation growth, and so we'll see some pretty bright greens that show up as a consequence. So we'll look at June and July as our months. And another important thing is the amount of cloud cover. Now, sometimes you'll want to get all images because the little area of your study area, who knows, there might be a window in the clouds and you could see it, and that would be great. But in this case, we want most of the image, if not all of it, to be cloud free. So I'm going to bring the percent down to less than 10% cloud cover. And let's hit the results and see what we get here. And we're getting a fair amount of images showing up. On the left, you could see the samples, and not all of them are perfect. Sometimes the flight lines only cover part of your study area. You can see the black on the left side of this first image, for example. If you click on the thumbnails, you get a larger thumbnail. Look at this one. We see it's missing a little bit in the bottom left corner, and also I could detect some high, looks like cirrus clouds in the image. So that one's not very good either. Let's scroll down a bit more. This one here looks like it has some potential. Do a quick look. I see snow-covered mountains. I don't see any clouds, and the whole study area, the whole ice field is visible. So that looks like a really good candidate. It was taken on July 4th, 2021, so it's pretty recent. And let's take a look at where the image covers on our main map. You just click the little footprint on the left-hand side and you, see a footprint. So it's covering a pretty broad area. And so let's go with this one. To do that, we'll click the Download Options button. A dialog appears, and you'll see that there's two options for downloading. The one on the bottom is only a 6.42 megabyte file. It's a false color image that they automatically produce of the area. It's a GeoTIFF, and it's a 20-meter resolution instead of the native 10-meter resolution of Sentinel images. But this image is, as we'll see in a few minutes, is very useful if you're just doing reconnaissance mapping of the area. We'll download that one, and then above it are all of the raw data band files of discrete parts of the electromagnetic spectrum. This is a fairly big download. It's 814 megabytes. I'm not going to download it right now. I did it earlier, so you don't have to watch the download progress bar on my computer. So let's go ahead and get out of my web browser, get offline, and in the upper right of my computer screen, you could see the files that we just downloaded. Let's take a look at the false color image that we downloaded. Again, it's 20 meters. You could tell it's rather false color, nothing much natural about this at all, but it's extremely useful. Look at how the snow-covered areas show up very well. We can see the glaciers very well. What's amazing is just how starkly the water areas appear against the land. They would be very easy to map if we were using this. And then you can see the bright yellow greens, which show vigorous vegetation growth, probably deciduous cutover areas or alpine areas in the spring, which are just coming into full bloom. And you can see there's a fair amount of detail in this false color image. So this is really a very handy image to use. Oh, and look at that. We have a little bit of cloud cover in some places on the image. So let's get out of this. We'll come back to it later. We also have all of the raw data bands that we've downloaded. To get to them, we have to do a little bit of drilling into the folder. First go to Granule, then you go to this next folder. There's img_data. We'll drill into that, and finally we get to the crown jewels that are available. Now, most of these are raw data bands. However, Sentinel does something nice. They also put another goodie in this download folder. It's the bottom one. It's at the end. It's labeled TCI, which means True Color Image. So Sentinel actually creates a true color image from the red, green, and blue bands. And sometimes this is very useful. I mean, you could just use this true color image for your mapping. But let's take a look at what they did here. And there's some problems. I think the first thing you'll notice is there's a lot of bright white in the snow-covered areas on this image. It's an automated process, and it clips out the brightest tones. So we have absolutely no slope detail in the mountainous areas. All we see is the bright flat white. And then the lowlands are quite dark and drab. It's hard to differentiate water from land. The drabness is largely a result of atmospheric haze and light scattering taken from the satellite far above. So it doesn't really look like the surface of the land as we'd see it if we were walking around down there. So unfortunately, oftentimes these true color images are not usable for more illustrative mapping projects. And what we have to do instead is go to the raw data bands and open them up and then composite them into an RGB image. The ones that we're interested in are bands 4, 3, and 2, which correspond to the red, green, and blue parts of the visible spectrum. You'll notice that the bands are saved in JPEG 2000 format. And to open up JPEG 2000 format images in Photoshop, Photoshop doesn't do it natively. You need a plugin. Fortunately, Geographic Imager has the capability of importing JPEG 2000 files very handily. The problem is it takes a couple minutes for these things to open. JPEG 2000 uses wavelet compression, and it's really tightly compressed, and it takes Geographic Imager a little while to untangle that compression. So I'm not going to open them right now, but the way you would go about doing it is in Photoshop, go to File, Automate in the drop menu, Import, Advanced Import in the drop menu. A dialog comes up, and then you click this button and select the bands that you want to open up that are in JPEG 2000 format. Again, we're not going to do this because it would take a couple minutes for them to open. I've done it already for you. The data bands are here in my dock. Let me get them out. And these three data bands are 16-bit grayscale images. We'll go to Image and Mode and check out this first one. You can see it's 16 bits. It's grayscale. The advantage of 16-bit data is the number of grayscale levels that it has. It's over 65,000 grayscale levels compared to standard 8-bit images, which only have 255 grayscale levels. What that means is we could do rather extreme manipulations to the composited image that we're going to create without artifacts like banding appearing. So it gives us a lot of flexibility in image manipulation in later steps. Okay, so we have these three grayscale images representing red, green, and blue. The trick now is to composite these into a single red, green, blue RGB image. To do that, we'll go to the Channels window in Photoshop, go to the top right flyout menu, and select Merge Channels. A dialog comes up. For the mode, instead of multi-channel, select RGB color. There's 3 channels, and what happens, what Photoshop does, it will composite these 3 images as red, green, and blue. Let's do a quick check here. Band 4 we know is red, it's in the right place. Band 3 is green, it's in the right place, and blue is 2, and it's where it should be. So everything is very good. We will click OK. And a RGB image has just been created from this raw data. Then what you see are a series of 3 save dialogues asking whether you want to save the original grayscale images. Click Don't Save, and Don't Save. They all disappear, and what we're left with is the RGB composite image of those 3 grayscale data bands. Looking at it, I could probably guess that you're not very impressed by what you see. it's pretty dark. It doesn't look like natural color at all. So this thing's going to need further manipulations to be usable for our purposes. And what we'll do first is apply a curves adjustment layer to it. Go to a layer, new adjustment layer, and we'll select curves. And we'll just click OK. And here's the curves dialog. Now, when curves originally comes up, you see the histogram in the background, that gray histogram showing the distribution of light and dark pixels in the image. And then we have a curve line, which is just a line originally. We could slide the sliders and make linear adjustments to the image. We can do the same thing at the light end of the line. Get an idea of how that works. Now, the power of curves is that we could apply non-linear adjustments to this image, and that's definitely something that we're going to want to do. So we could just put a click in the middle of the curve line, put an extra point in there, and create a curve. Now, I'm going to get rid of this extra point just by dragging it off to the side temporarily. And since some of the adjustments we're going to do are rather delicate, I'm going to get my info palette out. Let's just drag it out. I want to have it available so I can see the values that we're dealing with when we do a curves adjustment. And I am going to put a extra color sampler in here. The first thing I want to do is look at the snowfields and adjust the amount of darkness in there. Let's just find a typical area out in the snowfields. I'll click there, and you can see in the info palette it creates a new color sampler down toward the bottom left. Right now it's RGB values. My background is in print production, so I'm most familiar with CMYK values, and so we'll just switch that to CMYK. And look at that, the snowfields are now 29% cyan, 22% magenta, and 20% yellow. So it's kind of a dingy blue gray, and we definitely can improve on that considerably. So let's go back to layers, and we'll open up curves, and let's create a curve. I'll put a new point on the curve right here. And look at this, things are starting to lighten up considerably. I'm blowing out the snowfields right now. As you watch the info palette, it's now at 0%, so that's way too light, obviously. And so what we want to do is just fiddle with these curves so we just get the right amount of tonality in them. If possible, I try to create curves that have a minimum of points on them, but sometimes to get the effect that you need to put multiple points into the curve and just play around with it. It gets a little tricky doing this, so you'll want to experiment a little bit. So right now we have that rather grayish color in the snowfields. It's now 10% cyan, 7% magenta, and 7% yellow. And we probably want to get rid of the yellow in there at some point, and we'll look at that again. Now you'll notice that we put this curves in as an adjustment layer instead of just doing it on the image in a destructive sort of way. I prefer doing adjustment layers for a couple reasons. We're going to be doing additional tweaks to this image, and these additional tweaks will affect the curves perhaps, and so it's nice to be able to go back and adjust the curve if needed. Also, if you're going to be mosaicing several images together, you want to get the colors and the tonality of the images pretty similar that are side by side or adjacent to this image. And so by doing adjustment layers, you can apply these same adjustments to successive images in your mosaic. And the way to do that is just open up your curves adjustment here. If we really like this, go to the flyout menu and say save curves preset. And that will be saved, and we can apply that to the next image that we adjust. In fact, I did this earlier, and I saved a Stikine curve. Let's bring that one up. And it's kind of similar to what we just did. You can see there's all these additional points in the line. And let's take a look at the values in the snowfield. 8% cyan, 6% magenta, and 5% yellow. So that's getting better. And I think right now we're done with the curves adjustment. I think the image is getting a little bit better, but it definitely lacks warmth and kind of eye-catching pizzazz. We can fix that by copying and pasting that false color image on top of it. And let's do that. We opened up the false color image. Now this thing, again, remember, is at 20 meters resolution. The natural color image we're creating from the raw data bands, that's a 10-meter resolution. So what we have to do is up the resolution of the false color image. So let's do that. We'll go to image, to the drop menu, image size, and right now it's at 100%. So if we want to go from 20 meters to 10 meters, let's just put 200% in there. And for the resampling method, the default is bicubic smooth gradients. Since we're enlarging it, we want to preserve as many details as possible. So we'll select preserve details and click OK. And Photoshop will increase the image size. Now, upsampling is not an ideal thing to do, but we're using this false color image just to add a little bit of color and tint to the higher resolution natural color image. So here we are. The image has been enlarged. I'm going to just do a select all. I'm going to copy it, and now I'm going to close it. Don't want to save it. And what I'm going to do is make sure I have my top layer selected. I'm going to paste the false color image on top of everything else. And now the trick is to combine it down below. And usually the first thing I do is just keep everything in normal blending mode and just bring the opacity down and see what that looks like. And it's definitely warming things up if I bring the opacity down. But look at the snowfields. They've got kind of a strange cast to them that does not look quite real. So we'll bring the opacity back up to 100%. And we'll go to one of my favorite blending modes, which is soft light. The snowfields look a lot better now. And usually I use soft light and about 50% opacity. I think that kind of creates a nice natural color on most images. Since this is a demo, let's just kind of pump things up a little bit so you can see it better. We'll go up to, say, 70% opacity. And I think things are looking pretty good at this point. But there are a few problems still, and we'll do a couple more adjustments to correct them. Let's look at our color sampler in the snowfields. Right now, after we blended the false color image in, that's turned it to 13% cyan, 1% magenta, and 4% yellow. And I really don't want yellow in the snowfields. I mean, this is a high alpine snow-covered area. I don't think yellow is appropriate there. So let's do another adjustment layer to get rid of the yellow up in the snow-covered areas. So we'll go to Layer, New Adjustment Layer, and we'll go to Selective Color. Dialog comes up. We'll apply this to everything, and this is going to be pretty cool. Here we are. Open up Selective Color, and you could selectively change all of these broad color categories. We'll start off with whites because we're dealing with the snowfield, and let's just tweak some of the sliders here to get rid of that yellow. We'll bring the yellow down to minus 15 or so. There we go. Maybe nudge the cyan down a bit. Take a little magenta out of that. And let's just give everything a little bit more body. We'll just up the black ever so slightly. As you can tell, these adjustments are usually ever so slight to get where you want to be. So after doing those adjustments, we'll look down in the info palette and check that out. The snow is now 12% cyan, 4% magenta, no yellow, it's at 0%. So that looks very nice and like a cold, snowy surface. We'll zoom in a bit here. And let's just put our mouse cursor over some of the highlight areas. And in the upper right of the info palette, you can see that that highlight is 3% cyan and 2% magenta. Usually we want some value in the highlights. We don't want them to be completely blown out, and 3% and 2% looks pretty acceptable for the highlights. So we'll I think we've got that done nicely. I'll grab over here in the toolbar the color sampler. I'm going to select this color sample spot, and I'm just going to drag it off, and now it's no longer in our image and marring things. So very good. At this point, I don't think we need the info palette anymore, so we'll close that out. I'm pretty satisfied with land areas on this image.